Go. Hi everyone. Welcome to this edition of our four-part series, AI-powered content upgrades, brought to you by the Technology Integration Team here at Southwest West Central Service Cooperative. I'm Megan Hoffman, one of your tech integrationists, and I am so excited that you have chosen to check out this series. So today we're diving into a real-world example of how a group of 5th grade students used artificial intelligence to level up a classic STEM engineering activity. It's a perfect mix of pipe cleaners and physics and prompt engineering. So picture this. It was December in Minnesota. I was invited by the STEM teacher at our 3rd through 5th grade school to watch, aka help with crowd control during a busy activity, and help with testing the students' teddy bear zip lines. A few moments ago, you witnessed what the students accomplished before AI was even introduced. Pretty impressive, right? Well, let me tell you a little bit about the initial project. The teacher set the stage with a story. I just got off the phone with someone at the National Weather Service, and they said a giant blizzard is hitting the mountains soon, and we have a family of endangered snowflake bears that we have to rescue. It's an emergency. Now, being Minnesota kids, as soon as they heard the word blizzard, the room exploded. Are we getting out of school? Is it real? Wait, we don't have mountains around here. And once the critical thinking kicked in, the mission was clear. The students had to design a carrier to transport one bear down the zip line. The teacher continued the story. The experts have set up a zip line. It goes from the top of the mountain to the bottom of the mountain, so that you and your partner can rescue one of the snowflake bears. You need to design a basket that can carry one bear to safety. Here are our 3 goals. And she had these goals written up on the board. Safety. These are endangered bears. We don't want them plummeting to their deaths. Stability. It's a blizzard. Think about how windy it gets during a blizzard. We need the basket to go from the top of the zip line to the bottom without swaying. And speed. The basket needs to travel from the top of the mountain to the bottom in less than 1.75 seconds. The students had a menu of materials that they could use. They had strawberry baskets, they had red plastic cups, pipe cleaners, hexagram weights that were in increments of 1, 5, 10, and 20 grams, string, and pieces of fleece that were approximately 2 by 2 inch squares. But they had 2 strict constraints. Everything, their basket, their bear, anything that they put in or on their basket, the maximum weight was 175 grams, so less than or equal to 175 grams. And their basket had to attach to the zip line using a paper clip. That was just for simplicity's sake. We couldn't be taking the zip line, detaching the zip line and then reattaching it every time a student wanted to hook onto the zip line. This was a one-off project. Of course, if the students had had the opportunity to build and test and make adjustments and retest over multiple class periods, they may have had different outcomes. But in a school with 700 students, that would be about 350 baskets. The teacher didn't have that many supplies, nor the storage space for keeping all the baskets together. So these builders, these students, had 12 minutes to build their prototypes. Then they could do their first run down the zip line. Then if time allowed, they maybe had about 3 minutes or so to go back to the classroom and adjust and tweak their designs, and then do a second test run, and then disassemble their baskets and put all the materials away. So it was fast. They had to work fast and furious. Because of that, the tangible thing that we could measure was speed. And that really is what the students focused on. They found that they could add weights to make it go faster, but they didn't quite figure out how to handle the impact at the bottom or how to make it not wobble on the way down. While they may not have had enough time to get all the pieces figured out, I did hear some students pulling ideas from real life, what they could use in their designs. For example, there was one student who said, "I wear a seatbelt in the car. I wonder if I could make a seatbelt for my bear, because that will keep him in the basket and he won't fall out." So, they were thinking. And after being a part of this STEM activity, I asked the STEM teacher if I could work with a few 5th graders during her prep time. I wanted to see what would happen if we gave these students a little more time and a new resource: artificial intelligence. I did use these criteria as I chose which AI platform to use. 1, the AI platform had to meet the requirements of the Student Data Privacy Act. I was working with 10 and 11-year-olds. I couldn't just send them out into the wild of AI. 2, it needed to be familiar or easy for me to set up the persona. 3, it had to allow multiple groups to use the same persona at the same time. 4, it had to save the chats between the students and the AI. 5, it needed to be simple for the students to use. Bonus, if the students could speak to it instead of having to type everything. And 6, for me, it needed to be inexpensive. Double bonus if it was free. With all of this, I decided to use School AI to create a secure private space, and the students were able to easily join via a QR code, and they didn't have to use their names. When it asked for a name when they logged in, the group that used cups just wrote in cups, and the group that used baskets wrote in baskets. So there was one group that had 2 students in it, and they shared an iPad and shared that School AI space, and then the other group had 3 or 4, and they were using the baskets, and so they shared an iPad and an AI space right there. Now, I have to let you in on a little secret. I'm not a physics expert. Surprise, huh? So I used Gemini to help me craft this system prompt for the AI persona engineer Alex. And so that's how I got some of the physics vocabulary and some of the more technical things into the persona. And this is what the engineer Alex prompt looked like. So first I defined the role. Engineer Alex is friendly and enthusiastic. Engineer Alex is a project manager helping to guide 5th graders through the engineering design process. The mission, and if I were to do this again, I would rewrite the mission because we were not building the zip line. That was already up. We were building the basket to go down the zip line. And so I would rewrite that in the future. The criteria or the goals. I told Engineer Alex the goals of safety, stability, and speed. I told Engineer Alex about the constraints, about the weight, and the maximum was 175 grams, and that the students had to use a paper clip to hang their baskets on the zip line. So with the communication style, I wanted Engineer Alex to be very encouraging. And I thought the rule of one, and I'll give Gemini the credit on this one, I liked this one. The rule of one I thought was important because as the AI starts asking questions and deeper questions, I didn't want the students to be overwhelmed by multiple questions at once. And I also wanted Engineer Alex to use brainstorming clues to include vocabulary from physics such as center of gravity and friction, not fiction, friction and momentum. And get the students thinking by asking what-if questions. In the interaction logic, in hindsight, I might choose not to use these, except for the one about celebrate failure. Because, and the reason I say this is because when I looked at some of the responses that the students were getting from Engineer Alex, it seemed like they were always asked about the angle of the zip line. And that is really information I should have given Engineer Alex in the mission or in the constraints section, because the students didn't have the opportunity to change that. They couldn't change the angle of the zip line. That was set. So then when Engineer Alex would ask them about changing the angle of the zip line, they would just get frustrated because they couldn't do anything about it. Now, in all honesty, I did have some hesitation about having fifth graders use AI. It's the big question, when is it the right time for students to use it? And maybe the question more is, when is the right situation? Maybe that's kind of how I got around this, oh, they're really young to be using AI feeling that I had. And before we began, I asked these students what they knew or what they had heard about AI. And one student responded, "My mom doesn't let me use it because it gives you the wrong answers." Okay. Another student mentioned robots, and a couple of them looked at me like I had a unicorn horn growing out of my head. I also heard the concerns of some of the fifth grade teachers. And their concerns were that using AI might stifle the students' creativity. And so I really wanted to be cognizant of using AI as a tool rather than a way to offload the 4 C's, the critical thinking, creativity, collaboration, and communication. So I asked myself, will using AI just be a shiny new toy, or can it really enhance and encourage some real learning? Our technology integration group has been reading the book AI Optimism by Becky Keene, and she eloquently asks a fantastic question that I think will be important to teach students to ask themselves when they use AI, and that is, does this use of AI limit my learning? In her book, she uses the SAMR model, which was developed by Ruben Puentedura, to evaluate how AI can be used during classroom tasks and activities. Quick shameless promo here. Both Becky Keene and Ruben Puentedura will be speaking at our AI Development in Education Symposium on May 1st. It will be a fantastic opportunity to learn more about AI optimism and the SAMR model, and I hope you are able to join us. Okay, back to today. If you are not familiar with the SAMR model, let's break it down here in relation to this teddy bear zipline project. So the SAMR model, SAMR stands for substitution, augmentation, modification, and redefinition. And so in the substitution phase, that would be kind of like AI is a digital encyclopedia or a digital dictionary. A student asks, "What is the center of gravity?" and gets a definition. It's a direct replacement for a textbook, a dictionary, an encyclopedia, or Google. It does not change the function of the project at all. Augmentation. This is the smart assistant. Students tell the AI that they're using a red plastic cup and fleece, and they want to minimize the impact at the bottom of the zip line. The AI might suggest, try lining the cup with fleece to absorb the energy of the impact. It's personalized brainstorming that you can't get from a physical static book. Modification. This is the troubleshooter. So one of our groups told the AI very vaguely, our basket weighs 174 grams. The AI didn't just say, cool. It started asking questions. Where is the weight located? If it's at the top, your center of gravity might be too high. Now, the students aren't just guessing. They're making data-informed iterations. Of course, a teacher can help with this, for sure, but it might not be possible for one teacher to respond to all the questions from 20 to 25 students in a classroom. And then redefinition. This is the virtual physics consultant. Now, I would not say that we reached redefinition. Modification, yes. Redefinition, no. Redefinition would be the wow stage, where fifth graders could use AI to simulate what-if scenarios with complex math that would usually be way out of their reach. The virtual physics consultant could help them come up with scenarios to increase safety by creating more friction or changing the center of gravity. It could be a bridge the gap between the student's curiosity and the complex physics concepts that they don't know. So after we were done, I asked the students again, I asked them some questions, and I asked, when or how do you think it would be okay to use AI? And a couple of the responses were during free time or a fun activity or when my teacher says it's okay. That might have just been because I'm an adult in the school. I don't know. Then I asked them, when or how do you think it's not okay to use AI? And the resounding answer that I got was, on a test. Not okay on a test. And thankfully, they were still not convinced that AI will always give you foolproof answers. And we talked about the need to use critical thinking when we see things online. The most important thing, the most important takeaway for you is AI did not build these baskets. The students did. The AI simply gave them the vocabulary and kind of the nudge they needed to understand why their design worked or why their design didn't work. We didn't see a computer doing the work for them. It was a tool that helps students gain a new perspective or come up with a new idea. So our job isn't just to teach kids how to use tools, it's to prepare them for a world where these tools are going to be their collaborators. And if these fifth graders in a very short amount of time with very little front loading for this activity, if they can use AI to rescue a snowflake bear today, imagine what problems they can solve in 10 years from now. So thank you for joining me today. Don't forget to mark your calendars for our A.I.D.E Symposium on May 1st with both Becky Keene and Ruben Puentedura speaking. And also make sure you watch for the next edition, the next installment of our 4-part series, AI-powered content upgrades. And keep innovating. 3, 2, 1, go. Ready? 3, 2, 1, go.